Excellent. So we're all here. That's wonderful. In the user experience session D317. It's Wednesday, October 28th, and it's 1 o'clock CET. And it must be different in your time zones. So wonderful to see you all here in this fantastic virtual environment. And we have 5 papers today that we're going to have a presentation in the video of, and then later on we'll have a discussion. So normally we'll have about 5 minutes of video. So we're then 25 minutes further down the road, and the rest of the time we'll use for some discussion, questions, blah, blah, blah. You know how it works. I gather that we all prepared ourselves very well. So I will now shortly introduce the presenters. We have Priyabrata Rautray, if I say it correctly. If not, then just say it. He's doing his PhD in Hyderabad IIT, and he has worked also, it's a joint PhD with Swinburne University in Australia. So welcome to you. Then we have a paper presented by Clara Gandrez, if that's correctly said by me, or it's French possibly, Clara Gandrez. Yeah, and she works in a Renault company, and she does her PhD right there in a partnership with the Laboratoire de Conception de Produits et Innovation, LCPI, Améziane Institute of Technology, that's in France, I gather. And then we have Jason Millar. He's an assistant professor in the School of Electrical Engineering and Computer Science at the University of Ottawa in Canada, with a cross appointment in the Department of Philosophy. Welcome to you, Jason. Okay. And of course, we have Harry Felton. And apparently this is his first conference presentation. So, toy. And he is doing his PhD studies in mechanical engineering at the University of Bristol in the UK. And well, I'm really interested in hearing what you are doing, because it's about 3D printing, etc. So it's really interesting for me. Sorry to say that. And then we have MS Pap. I think that's right. MS Pap. She is from.
but it's okay.
No, please go. How do you say your name?
It's Amesha.
Amesha.
Correct.
Okay, excellent. Thank you.
Amesha
Pap is a research associate at the TU Dresden in Germany, and her research work is focused on wearable assistive devices such as exoskeletons. So welcome to you all. We're going to have a really beautiful session with some very interesting work you've done. But before I'm continuing, I have to congratulate 2 participants in this session. And of course, the first one is MS Pap. You were one of the top 10% authors with papers that were reviewed with a high score during introduction, and you will receive the reviewers. Yeah, you will receive the reviewer's favorite certificate after the conference. So congratulations to you, MS.
Thank you so much.
Keep up the good work. And then another congratulations goes to Jason Millar. Congratulations to you too. Same thing applies to you. You have the top 10% rated papers by reviewers.
Oh wow!
And,
thank you.
You will also receive a reviewer's favorite certificate after the conference. So congratulations to you. Wonderful. Keep up the good work. And now we will run the videos shortly, and then we'll get back to it. Okay, so please, yeah, that's it. Thank you.
Hello everyone, I am Priyabrata Rautray, a joint PhD scholar from IIT Hyderabad and Swinburne University, Australia. During my research on passenger drone, the need to understand user perspective was found to be vital for its development, and this paper presents the result from an online survey of potential users. The online survey was designed to find the unmet needs of prospective users such as acceptability, perception, travel choices, traffic issues, user needs, wants and concerns, and so on. We were especially interested in getting a broader perspective of user insight. The user survey was generative in nature, where the designers were informed before manufacturing process. The survey was divided into 3 segments. The first segment was on demographic and travel behavior. The second segment was quantitative in nature and dealt with relative importance of different issues related to transportation and design. The third segment was qualitative in nature and had open-ended questions to explore the positive and negative associated with passenger drones. Now, coming to data analysis, the data from the first segment, that is demographic and travel behavior, were analyzed by taking the highest frequency of the multiple choice questions. We found that a large part of young working Indians regularly travel in congested traffic and were looking for an alternative mode of intra-city transportation. This also entails a considerable amount of time lost in commuting every day, which could otherwise be used towards personal prosperity or even contribute to the economic growth of the country. Trendy design, modern amenities, sustainable system, user comfort, intuitive and interactive interiors, and a system that can work on both land and air are some of the key insights from this segment. In the second segment, where the users rated the issues of transportation and design elements on their relative importance, the responses with higher means were considered as key points, and the methods or activities that can resolve these issues were listed as suggestive design parameters. The third segment gave a few unique insights about the user perception of passenger drones. A process of acquisition, definition, decomposition of customer requirement was followed. Using the process of semantic decomposition, transformation, mergence and supplement, and by consistency scrutiny to derive these parameters from the open-ended questions. If you look at both these charts, the middle columns were the key points derived from the qualitative and quantitative data sets, and the method or the activities on the right of the chart were the suggestion to mitigate such issues. Finally, following were the insights from analysis of user survey data. Design of passenger drone should be able to reinforce the feeling of security in all aspects of build form, material used, cabin space, and others. The design of daylight opening should promote 360-degree view. The cabin space should reduce the feeling of vertigo and claustrophobia. Interaction with the vehicle should be natural and intuitive. Every aspect of the product should be able to encapsulate the notion of speed. Autonomous system should be able to handle the majority of flight operation to avoid disruption. Passenger drone should be cost-effective and commercially viable to make it more affordable to common people. And to conclude, this was first of its kind of user survey on passenger drone in India, but due to limited sample size and uneven distribution of result, the survey should be used as suggestive measure rather than prescriptive design parameters. Thank you all for your time and have a great day.
PhD student, and I will introduce you first result on the assessment of drivers' risk perception during autonomous driving. This is a thesis in collaboration between Renault Company and the Laboratoire de Conception de Produits et Innovation at Arts et Métiers Institute of Technology in Paris. Firstly, I'd like to introduce you the scientific and industrial context of the study, as well as the research program made. Then, I'll present the experimentation that was carried out to solve the research question and the achieved results. In the autonomous vehicle context, the security aspect is very important. The driver entirely delegates their actions and have to own an absolute confidence in the car. The risk perceived by a driver has been studied for a long time, and many variables have been shown as influence on driver risk perception. However, in the autonomous case, new factors have to be taken into account, as the lack of control, the nature of the risk that implies very new technology, or the lack of familiarity with this technology. All these factors can imply new cognitive and emotional commitments from in the driver with negative emotional aspects. The driver emotional perception is becoming an essential challenge in the autonomous vehicle development. A question arises, which factor influence the driver risk perception in the autonomous vehicle case? For this, experimentations have been carried out. 16 near crash scenarios were defined thanks to an experience plan created using the Taguchi's method. Scenarios are defined on an autonomous level of 3 and are based on the same storyline. After following a vehicle on the highway, there is an apparition of a stopped traffic jam where the preceding vehicle brakes, less or more strongly, and in which 4 variables are studied: the effect of the weather, ideal condition, or thick fog, the type of the preceding vehicle, motorbike, truck, or car, the distance to the preceding vehicle when it brakes, very near at the safety distance or far away, and the deceleration strength arriving in the traffic jam. Then the scenarios were run on a dynamic simulator Ultimate. 218 French drivers have participated. Among the participants, there was 112 women and 106 men that permit to respect parity in the population sample. In addition, every age range has been studied. Participants were aged from 24 to 71 years old. For the driving levels, the population sample corresponds quite well to the French driver repartition. From the Natashan scale of confidence, where the participants had to rate their confidence during the final braking on a Likert scale from 1 to 5, a significant difference between men and women is observed in the risk assessment, as you can see in the bar chart, where women assessments are represented in light gray and men in black. The difference in risk perception between men and women was already studied and demonstrated multiple times, but this difference can also be applied to the autonomous vehicle case, and it can confirm that the gender of the driver influences the risk perception and their confidence in the autonomous vehicle. Another parameter influencing the trust placed in the vehicle by the driver is the participant's familiarity with driver assistance system, especially with cruise control. A driver accustomed to cruise control felt less anxious than those who didn't use it. This is a new factor that influences risk perception compared to manual driving. This observation was already made in the German population. So, a self-driving car driver's risk perception decreased as experience with driver assistance systems increased. Among the 4 factors studied that impact the perception of risk, the most relevant ones were the deceleration strength, with an impact over 50% on the risk perceived by the driver, followed by the stopping distance if it is under the safety distance, with an importance over 55% on the perceived risk. On the other end, the weather conditions, including reduced visibility and the preceding vehicle type, do not significantly affect the risk assessment for autonomous vehicles driver. In conclusion, this study allows to have a closer analysis of how risk perception is felt and expressed by an autonomous vehicles driver. New factors relative to the risk have to be taken into account for the autonomous case as personal factors and new risk factors. Moreover, experiments were conducted on driving simulator, and results must be compared with the real autonomous vehicle due to the simulator biases. This study will be extended on a larger population sample, particularly with drivers from other countries than France. Indeed, this risk perception depends on driving style, which is personal for each country. Successfully determine in which psychological state is the driver can be used to adapt the driving style of an autonomous vehicle. For example, if the driver felt anxious. To know the vehicle's actions that cause stress to the driver, allow to develop the automatic conception. Take into account the customer feelings upstream in the vehicle development cycle, and third, the autonomous vehicle acceptability on the automotive market. Thanks for your attention.
Hi, everybody. Welcome. I am going to be discussing a paper that I co-authored with Dana Paz, Sarah Thornton, Celeste Parisi, and Chris Gerdes. This is based on some research that we did at Stanford University and in the Bay Area in 2017, 2018. The paper is called A Framework for Addressing Ethical Considerations in the Engineering of Automated Vehicles and Other Technology. So the motivation behind this research really came from policymakers who in 2016, 2017 started signaling the need for engineers to consider ethical issues and to put ethical considerations or to address ethical considerations in the design of automated vehicles specifically, but certainly other technology, robotics, and artificial intelligence generally. We've seen that in the last few years, a lot of policies and declarations coming out specifying various principles that should be adhered to in the responsible design of robotics and artificial intelligence, automated vehicles included. We saw this specifically in 2016 with the Department of Transportation in the US issuing a policy document on autonomous vehicles or automated vehicles. And they called specifically for engineers to demonstrate that they had considered or addressed ethical considerations in the design of those technologies. And what was interesting about the Department of Transportation case is that industry responded and largely was saying, well, we need some guidance on this. We need further guidance on what it means to address ethical considerations in the design of automated vehicles. And so as a research group, at Stanford at the time, we got together. We were interested in these ethical issues anyway, and we decided to provide or develop a sort of framework and answer the question, what does it mean, or what would it look like to put ethical considerations into the design of this type of technology? And so in order to address that research question, we developed a framework. It was based largely on value-sensitive design. So this is a design framework that is generally used to bring values-based considerations into the design process. We wanted to address some specific engineering needs. So we wanted to make the framework that we were developing a little bit less open-ended, a little bit more, to provide more specific prompts to engineers in order to bootstrap that process a little bit and leave it a little bit less open-ended for engineers. We found we thought that would be a useful addition to the research. So we developed a prototype framework, and what we did was we ran a series of workshops, design workshops, over the span of about a year to validate the framework and test some of the tools that we were providing as a part of that framework. So the framework includes a loosely defined process. You can read about that in the paper, and some tools, specific tools and decision points and steps that we were using to help engineers anticipate a broader set of ethical issues related to their technology, broader than they would maybe normally have the tools to just consider on their own. And the series of workshops was a way for us to test whether or not we were accomplishing that goal of providing a framework that kind of bootstrapped that ethical considerations process. So we ran it with several different groups over the space of months. And just to report briefly on the findings, overall, when we were, as a part of the design workshop at the end, we were doing our data collection and asking people how useful they found the workshop, whether they could integrate it into their work, whether they needed more supports in order to use some of the tools that we were providing. And overall, what we found was that it was indeed it seemed like a useful framework to help engineers to consider ethical issues that they would not normally have considered. The tool and the structure around the tool and the framework also provided they felt it provided space and structure around having these conversations that maybe didn't otherwise exist. So that's briefly a synopsis of the paper. You can read much more about the tools and the framework, and I invite you to do that in the paper. Thank you.
Hi, I'm Harry Felton from the Design and Manufacturing Futures Lab at the University of Bristol, and I'll be talking you through my paper, Looks Like But Does It Feel Like? Investigating the Influence of Mass Properties on User Perceptions of Rapid Prototypes. As the title suggests, the paper aims to investigate whether the mass properties of a 3D printed prototype affect how a user perceives the prototype. In the coming slides, we'll briefly look at a little background to MEX, how the study was undertaken, and finally, summarize the results. MEX offers a cheap, easy-to-use method of fabrication for prototypes that is able to relatively accurately replicate design geometry with little user input. The parts produced using MEX are normally formed of an outer shell, shown in grey in the top right image, and a lower density infill pattern, shown in white, to reduce print time and cost whilst maintaining suitable part structure. Similarly, to save cost, parts are generally printed in a thermoplastic material, often PLA, ABS, or nylon, when they would normally be fabricated using composites or metal, or have other components incorporated into their structure. This often leads to poor matching between designed and printed mass properties. It is hypothesized that this poor matching may be problematic, with the mass properties thought to be an important part of the perception a user develops of a product. This is briefly discussed in work published by Hewden Hill that used a pizza box with a brick in it to resemble a laptop in a user study, though this work stopped short of discussing any results. As such, it was thought a more detailed study would be beneficial in investigating this hypothesis, with results demonstrating how the effect of mass changed user perceptions. This brings us on to the main work completed for this paper, a user study. The study was designed around the Automaker hand drill that had been modified to provide pockets in the upper and lower sections where the motor and battery would normally be placed. 3 artifacts were fabricated using PLA, lead pellets, and iron filings, with the production of drill 3 shown in the top right of the slide. All the drills used the same print settings and materials to ensure they looked the same. Drill 1 was an unmodified drill. Drill 2 had mass added to the base of the drill, and drill 3 had mass added to the top of the drill. This was done such that the mass and center of mass position, relative to the height of the drill, were different for each artifact. The students were then asked to undertake an activity with the drills that had been fitted with 8.5mm drill bits. This involved pushing the drill bit through 6 10mm diameter holes in the sheet of acrylic in a predetermined, consistent order. The sheet had obstacles added to it to force each participant to turn the drill to complete the objective. To ensure the task was performed with an unambiguous objective, a prize was awarded to the participant who completed the task fastest with a single and all 3 drills. After completion of the task, the participants were asked to fill in a survey with the 3 questions shown on the slide. The participants initially answered these questions without any input from the interviewer, but their answers were then discussed to understand meaning. This provided the results shown here. Before discussing the results, it should be noted that the order the drills were used in was selected by each participant and was nominally random. Though drill 2 was used slightly more often than any other, there is no obvious correlation between the order the drills were used in and the answers the participants gave to the questions. As can be seen from the table, drill 2, the drill of the median mass and lower center of mass position, was the preferred design, based on mean score and the number of times selected as the preferred design. Though it was unimportant which drill was considered best for this work, it was important to note that participants were able to score the drills differently and select a favourite. This is important as this demonstrated that variation in mass properties could significantly affect how a user perceives otherwise identical prototypes. The next set of results, presented in the figure, look at how the participants recognised each mass property in questions 2 and 3. As can be seen, mass was easily the most recognised property, with balance and moment of inertia being recognised less often, in that order. It was thought that this was because these properties were more poorly understood than mass by the participants, though it is also recognised that mass was likely to have a more significant effect than moment of inertia for the task laid out. It should also be noted that although the task was timed, the performance of each drill in the task did not show strong correlation with the scores the drill received on a case-by-case basis, highlighting that mass properties were obviously an important consideration for the participants. And so, this brings us on to our conclusions. The 3 main takeaways from this paper were firstly, that all participants were able to clearly recognise differences in mass. Several could recognise balance variations and a few recognised different moments of inertias. Secondly, that the participant scores appear to have been more heavily affected by the mass properties of the artifact over their performance with the artifact. And 3, for work not shown in this presentation but discussed in the paper, the industry recognised that mass is important for user interaction but can also be a design driver in its own right. So thank you for watching this presentation. The paper is available open access as part of the Design 2020 proceedings, and I would invite you to read more about this work in the publication.
Hello everyone, my name is Améziane. I'm a research associate at the Technical University of Dresden at the Chair of Industrial Design Engineering, where we develop experience-centered technical products and systems. The work I present today is based on a part of my diploma thesis at the company Ottobock, and it's focusing on a passive exoskeleton, the Pexo shoulder, which relieves strain on the shoulder joints and upper arms during overhead work, for example on assembly lines and in the building trade. Probably you have already heard about occupational or musculoskeletal disorders, which are the most common cause of lost working days in Western countries. Nevertheless, physically demanding work is essential in many sectors, as the automation of certain tasks is not possible for economical and technological reasons. In this context, personal prevention measures, such as wearable support devices, exoskeletons, gain in importance. Exoskeletons are quite new in the industrial field, and their application is often accompanied by acceptance problems, which is also understandable since the development to date have mostly focused on technical implementation, while the needs of the users came second. Therefore, in this presentation, we won't talk about the exoskeletons, but about the people who are wearing them. In the next slides, I will give you a short overview on the basic terms of acceptance and the user experience research. Success and acceptance of products depend on objective and subjective aspects, which are the so-called instrumental qualities like effectiveness, ergonomics, reliability, and non-instrumental qualities like aesthetics, identification, pleasure, and meaning. Acceptance research traditionally focuses more on the instrumental qualities of products, but the relevance of the positive experience in the working environment is increasingly underlined, as it affects well-being, motivation, and performance. These are non-instrumental qualities and their emotional experience, what user experience deals with. In order to gain relevant insights for the development of next generation's exoskeletons and avoid acceptance problems, we wanted to examine how acceptance for exoskeletons emerge, which interrelationships exist between user experience and acceptance. What special aspects does product interaction entail when it takes place on the user's body, and what role does this play in the user experience? The goal of our study was to collect qualitative information on users' individual needs in relation to the exoskeletons in industrial use. In the context of my diploma thesis, I could be part of a pre-pilot test in 2018 at the Audi plant in Győr, Hungary. Since Hungarian is my mother tongue, it was a great opportunity to meet users in field under conventional working conditions. In order to measure product experience, I conducted a field observation and guideline interviews on the Rautray assembly line. Based on the interviews, it was possible to determine and describe 5 psychological user needs that were significant for this context. The need for security is essential for the users, but it is a basic requirement in a professional context. Autonomy and competence are also important, but are associated to the working environment and not to the exoskeleton. Comfort was classified as crucial as wearing comfort and also as a factor of effectiveness in the work performance. Physical thriving was given a further meaning in this context. It was not only interpreted as the momentary experience of physical well-being, but due to the preventative character of the system, also as a confrontation with possible illnesses and one's own weaknesses. Many of the test persons admitted only unwillingly or sometimes not at all that they needed support in completing their work. Thereby, the need for physical thriving relates to the need for self-esteem as well. It became very clear during this pilot test that people who accomplish physically demanding work are proud of their own physical performance, and the use of assistive devices should allow this. The main conclusion that can be drawn is that identification of exoskeletons shows an associative character, and their usage can have a considerable impact on the user's self-image. These findings enlighten the question of technology acceptance from a new perspective and highlight the relevance of user experience in a professional context. I hope you enjoyed this short presentation, and I'm looking forward to an exciting discussion. Thank you for your attention.
All right, thanks for the presentation. I think we heard some really interesting topics and listened to some great results. So let's see if there are any questions, of course, from the public. But I also have some questions that might be relevant. But first of all, and I will watch the chat box and see if we can get some of these questions going as well in the session. So we're all trying to investigate and research on user experience. But what I found really interesting initially is that when Priyabrata was starting to talk about drones for people in modality of transportation, that's an experience right there, but it has also a lot of ethical consequences, I think. So did you consider any of that, Priyabrata, while doing this research? Can you hear me?
Yeah.
Hi.
Can you repeat the question? Yeah.
Pardon?
Can you repeat the question?
Okay. Yeah, I thought it was what I found interesting is that you are trying to see if it's feasible to use drones for public transport. And that has two sides already. It's a user experience because it's quite demanding, I think, psychologically to go into a drone. It's an autonomous apparatus, but at the same time, it has also ethical consequences in an environment as busy and overcrowded as your context in, I think, India, but even in other contexts in the world. So maybe you can elaborate a little bit on that.
Yeah.
Did you consider any of that? Yeah.
Yeah. So when we started this research as a pilot study, because we see there are many companies in the world who have already are in different stages of development of passenger drones, but then these concerns of users were not much accounted or documented. So when I found this, or when we discuss about these ethical issues, we found one was the issue of privacy, and the other was the issue of autonomy. If will you travel in such a vehicle which is not controlled by you, and then there is this issue of will this autonomy will save you or save number of people on the ground. So these are few of the issues that were featured in our survey, but more research and discussions are required on a larger scale to understand such issues.
Yeah, I understand. So could I have your opinion on that, or maybe your statement on that, Jason? Maybe you have some things to say about that.
Yeah, thank you. So can you hear me okay?
Yeah.
Okay, perfect. Yeah, I think, I mean, just touching on maybe the intersection between the work and the work that that I take Priyabrata is doing, as I understand it. You know, the even in generating the kind of survey that would address particular ethical issues, what we were trying to do was create a framework that sort of you could step through and really engage with engage with issues that would impact a broad set of stakeholders. So it would, like if there was some sort of generation of a survey to try to understand, you know, what people were thinking about drones, like passenger drones, certainly the framework that we were developing where I think that would fit in would be, you know, upfront when it's like you're sitting down as a group, as a design group, trying to think through, you know, various features that need to be included in these types of systems like passenger drones. But the methodology that you use is to sit down and kind of go through this broad stakeholder, what we would call value mapping. So where you sit down and you really think broadly about direct and indirect stakeholders. So not just the people in the vehicles, but the people outside of the vehicles, maybe policymakers and and a whole group of different stakeholders to try to understand what are the values that are attached to those individuals, where you in relation to these types of passenger drones, and where you might see value conflicts or value tensions arising in the design process, and then focusing on those value tensions between, say, Priyabrata mentions like the idea of making choices between saving people on the ground or saving passengers in these drones. Like, how would you resolve those types of situations? So what we did in our project anyway, in developing the framework, was provide specific prompts that engineers or policymakers or whoever could use to think through those types of tensions, and start resolving them using some of the strategies that we're providing. So, balancing out values and.
Sorry, Jace, to break in, but
Yeah.
I like to also have some opinion or statements from Clara and MS and
Yeah,
Harry.
absolutely.
Thank you for the moment. And so we have demographics also. We see prototyping going on. We see a lot of interactions happening before you can even apply, let's say, a system based on drones in society, with all the ethical implications, but also the psychological and emotional implications. So there are two questions related to gender, and I would like both of you, Clara and MS, to maybe elaborate a little bit on how is gender related to your study, and is there a large difference sometimes noticeable in your findings and results? Could you maybe elaborate? Clara, I can't hear you. Your microphone is off. Clara? MS, could you maybe?
Yeah,
thank you.
So I have to be honest, I don't have too many experience with female users, because most of our users were male. So also the tests were conducted with male users. And but this is also a problem, of course, because it's harder to implement issues which are, it's harder to implement problems female more involved with. So it would be really good if we could conduct tests again where we can also ask and interview female users. Yeah. So unfortunately, I can't tell you too much on this topic.
No, but I think it's interesting because, gender is going to be more and more included, of course, in all the processes, and even in manufacturing, which is wonderful. I think it's a very good step and should be enforced more and more. Clara, can you hear me? Could you maybe elaborate a little on what your thoughts are on gender and in relation to your research, but also in relation to the topics we just discussing? I can't hear you. No, I can't hear. So, no. Your microphone is still... Can you unmute your microphone, Clara? I cannot do it. Push the button on the mic. Anyway, let's. Okay, that's really strange. I can't hear you. Maybe you should refresh it otherwise. Anyway, let's continue with the conversation. So, Harry, can you hear me? Harry?
Hey, hopefully you can hear me.
Do you have any comments on some of the presentations you heard, and maybe some on user experience, because you do a lot of stuff on user experience in terms of prototyping, and how valuable is a prototype, and is a prototype, what is a prototype when you make a prototype, right? I mean, these issues are relevant to you. So Could you maybe expand a bit on that? In the meantime,
yes. So
yeah.
if I consider I know there are 2 questions on gender, for example, from the audience. So for my work, I didn't explicitly consider gender, but moving forward, we've been considering part of the inclusive design toolkit from the University of Cambridge, which instead of looking at classifications of people, tries to look at the issues that actually drive how people consider things differently. So as an example, people with disabilities involving the use of fine control in their hands, for example. So that may not necessarily have a direct relation to individual diseases, as an example, but it's a specific cannot do a certain task, and then how that would play into the role of prototypes. So for my work, I'm looking at what sort of threshold is there in terms of what is a noticeable difference in mass, balance, or inertia, and at what point does that stop being a relative difference to an absolute difference. I think we're coming to the conclusion that it's probably too complex to do in the time I have, but we're trying to make sort of early inroads there to try and suggest future work for others.
Okay, I have to break in because I have a question in addition to that, Harry. It's from David Jones. He's asking you, is there an expectation that mass inertia testing will become standard practice early in the design process, given as equally important as form, for example?
I think it's probably quite product dependent. So some of the parts that we've been looking at are like a Nintendo Switch controller, games controller. So I think for something like that, where you're going to be picking it up and interacting with it in lots of different ways, mass balance and inertia testing probably will become quite an important thing, especially early in design. And there are 2 ways of looking at that. It's, do you design for what a user wants, or do you just check that your part can be used in the method or the way that you want it to be used? So I think it's kind of twofold. I think there will obviously be some products that just don't require it. A parking meter, for example, you don't need to worry about the mass balance or inertia, but anything I think you interact with by picking it up is going to become a more important consideration.
Mm-hmm. I listened to your talk, Himes, about that people in the end were really proud of their own capabilities and capacities and strength. That is very relevant, I think, also in your research. Like, that is maybe also a thing for gender again there, but at the same time, this maybe applies to everybody, no matter what gender you have. How do you work with outcomes like that? I'm really interested in that. Like, how could that, be used in advantage?
So this is the basic, this is our, the basic statement that people they are proud of their own performance. So what we think that the products that we create, these wearable products, they should allow this. And to do so, they have to underline the capabilities of the user. So it shouldn't look like something like helps. It shouldn't look like as an assistance system, but probably it should look like as I don't know, like more like a sport device, which can help you to use your to use your full performance. So I guess I saw also a question. This is, of course, also part of the aesthetics, how the product looks like, how it feels, and how the user, how the user's perception on this product is. So they shouldn't think that they look, I don't know, like sick or ill with the product. They should feel more powerful with the product. So I guess this is also important, how they can disappear in front of others. This is also really important in this question, like how you are working with others, because your self-image is not something which only yours. It's always related to your surroundings, to the company, to your colleagues. So there are a lot of factors you have to consider in this case. And this is always the question, how you can present yourself in front of the others and in your special context. And the product we create, an exoskeleton, should help to to improve this position in this hierarchy at work, and not I don't know, feels like losing strength or health.
I understand. So I have a question for you from Bahar Ashafani, and she asked about if you consider aesthetics as part of the product characteristics. Maybe you can give a short answer on that.
Definitely. And aesthetics is a really important part of the development of the product, because it's also, we're using aesthetics also for usability reasons. So we try to combine the aesthetics with the usability task, like to find all the parts you have to find, like how to interact with the product. So aesthetics is important on that level, and it's of course important on the level I was talking before, how you appear in front of your colleagues and in your working environment.
Yeah.
And like our observations that the exoskeletons, these wearable body-worn products, shouldn't be too, how you say it, they should, should be more decent, probably. So it's not like something, not like a power tool you just holding in your hand and can put it down in every second. It's something you would wear the whole day. Whole time, so it really became the part of your image. So it shouldn't dominate your appearance, but it should be a decent part of it.
Right, it's a very nice touch, the decent part of it. So Clara, you're on. You can speak now. I think your mic is working, right?
Yes, do you hear me?
Yeah, I can hear you. Great.
Yes,
so
it's better.
Yeah, so what about yeah, I mean, your work has really some affinity and overlap with what MS is doing. What are risk perceptions, and how do you deal with that from a gender perspective, if I can ask you that?
Sorry, could you repeat the question?
Yes, I think you have some overlap with MS's work, and maybe you could elaborate a little bit on the risk perception in your work, and also when you use exoskeletons, you know, in the work of MS. Maybe you can elaborate a little on that. How are you dealing with that? And also, are there differences in visible in your studies in gender perspective?
In our study, we define the risk, the perceived risk, as confidence put in the self-driving car. If driver felt anxious or in danger, so he has less confidence than he feel great. But I don't really know the relation with the MS work.
I have a question actually for Clara, and I guess it would be a little bit the connection between our works. I have the feeling that what you're describing, that if the driver is anxious also whatsoever, probably it's also like how they trust their own abilities. I mean, is that a relation between the driving abilities of the person with the trust in the autonomous driving system? Because I have the feeling that in my case with exoskeletons, if a person has more more idea how the body is working, like somebody who's doing more sport also understands better how an exoskeleton can work on the body and accepts it more. So maybe it's totally the different in your case, but I have the feeling that like how educated you are or how you trust your abilities, your own abilities, it has a big impact on your perception.
So, you think if a driver has more knowledge about the working of the autonomous vehicle, he will win in confidence, like for your exoskeleton?
Repeat it, I didn't understand you somehow.
You think you say that like if the driver has a knowledge about the autonomous vehicle or a training in it, he could be more confident.
No, I can imagine that in your case it's actually the opposite effect, that somebody who has like really good abilities, in manual driving, maybe would trust less a system like this.
Okay.
I don't know.
I think we have a very good discussion here. This is wonderful. Maybe you should continue that. I like to switch over to Jason because we also reach into some of these ethical questions and related to our perceptions, and also working with autonomous vehicles or autonomous systems or skeletons, if you will. Things are going to change interactively also in our experiences, and maybe you can elaborate a little on that, Jason. And I also like Harry and Priyabrata to maybe give some comments on that, please.
Yeah, I guess I wanted to comment on, maybe this ties into this question on Emesh's work, because I found it really interesting just to hear how she was talking about how we would frame this as a value tension between perception of their own abilities and the pride that they take in their own ability to do particular work, and the impact that the exoskeleton has on that self-image that they have of themselves. Mm-hmm. And the way that you could frame the exoskeleton as either something that's on the one hand fixing a deficiency that they have in their ability to do work, versus kind of supercharging them to be, almost like superhuman. Like me and my suit can do things that were never possible before. And I think we see that in other autonomous systems, whether it's in other robotic systems or just in AI, where the design process, I think, needs to take in these types of tensions between people's willingness or ability to adopt certain technologies because of the way that it impacts their own self-image. I think that's huge. We've seen that in artificial intelligence systems when you're talking about augmenting people's abilities to do things in the workplace versus replacing them, in some way. And I think that to a certain extent gets at what Emesh's work is touching on. It's like the exoskeleton can be seen, if you think of that as a kind of automation of strength or something like that, the exoskeleton could be seen as something that's either replacing them or augmenting their capabilities. And it's a great tension. I love that her work drew that out. And
it's like a potion, right? It's like a potion, like an Asterix or $1 million man kind of thingy.
Yeah, exactly. Yeah. So it's like, and I love how, and I think design can really do, and this ties the aesthetics in, I think, because you could design a thing to appear as one or the other. So Emesha is like talking about how it can't look like an assistive device. It needs to look like more like a sports device or something like that. And that's like just a turn of, shift in the way that the perception based on aesthetics would communicate those abilities, or that, like, the role of that thing in that worker's.
Yeah,
like,
it's interesting also.
Fabric.
It's interesting what you brought in just recently, Jason, is that the word AI. I mean, in how much of the AI or machine learning coding is being part of your work? Clara, Messed, are you, all you guys and girls, are you working with AI and ML in your studies right now? Is that a part of your studies, or is that still not, feasible? Or
yes.
Go ahead, anybody.
Okay, so For passenger drone to become a reality, AI plays a big role.
Yeah.
I believe as designer, we have to bridge this gap between technology and the user experience or the user needs. I believe what was not possible in past has become possible due to technology, and what we are discussing right now, I hope will be a reality in near future. So as designer, we have a great responsibility to make this transition as smooth as possible. Like Jason was saying, to reduce this tension between different components. And I think AI will play a big role when a lot of this manual interaction with the environment is processed through a system like signaling, like your destination, like something like Google Map, which is just directing us to the destination, and we don't care which road it's taking or how it is taking us. We just see it's the shortest and the fastest route.
Okay,
and
thanks.
we just follow it.
I have to cut you short because I need others to say something too. Clara, can you maybe elaborate a little on AI, ML? Yeah, please.
The final purpose of is to generate a predictive model of the driver emotional state, and we hope use AI algorithm.
Excellent. Thank you for that. Mes, comments, please.
We are actually still on the very traditional way, like the exoskeletons are working. They are passive, so they are don't have any electric components. And also in the testing, we don't use yet anything comparable.
Yeah, but you could use sensors and stuff. And
we are
build
thinking
scenarios
about it. Exactly.
Yeah. I think you should maybe look into it.
Yeah, but of course it has some ethical questions
of course.
This as well. So it would mean that you are actually observing people at work.
Yeah.
And it's really tricky.
I know, but that makes it beautiful. Harry, could you maybe expand on that? Because prototyping is a very important thing. I think even in the work of Priyabrata and all the others, it's relevant to have prototypical scenarios, etc. Could you maybe expand a little on AI and prototyping, and just shortly? We have a couple of minutes left.
Yeah, I'm by no means an expert, but I think it's interesting that when people are asked for technology to look after them, they think of the worst case scenarios, and when they think that they're looking after themselves, they always think of the best. And I think there's definitely an interesting problem there that AI could definitely help with in trying to, as Clara alluded to, trying to predict people's emotional states and how they understand risk. I think would be a particularly interesting piece of work.
Mm-hmm. Thank you. Thanks. Jason, could you maybe expand shortly, just a small comment on anything we just talked about?
Yeah, so on the use of AI, I can comment on the use of AI. Sorry, my kids are just leaving for school, so they can't answer the rule. One of them was asking me to feel their forehead to see if they felt warm. And, this is the state we're in. Certainly we interact a lot with researchers who are using AI. My students are many of them trained in AI ML, and we're starting to work it more into the driving simulation and automated driving research that we're doing in collaboration with a group in Braunschweig in Germany.
Great.
So more and more, and I mean, the focus of my work is certainly applications in AI, although I don't typically develop or code AI as part of the research, but that's something that's starting to work its way into my research now.
Excellent. Thanks for that, Jason. I thank you all for being here, for being a wonderful, set of session people. Great content. It was really nice to see you all, and be safe. And I think we don't have a lot of time left. I think a couple of seconds. If anybody of you want to say something, go ahead, shout it out. If not, then I thank you once and all for being here with us. And maybe we see each other in that virtual space, which is really weird. You can walk around with your, whatever. I don't know. Thank you, and be good. All right.
Thank you, everybody.
Yeah.
Bye-bye.
Thank you.
And thanks
Nice
to
meeting you all.
Jasmine.
Bye.
Thanks, Jasmine, for your assistance.
Bye.
Thank you.
Bye-bye.
Bye, everyone.
Bye bye.